So we are now ready with the canonical LR0 collection of items. So we have 6 states I0 to I5, and we have the augmented grammar, and the original grammar we have two productions, S gives ASB and S gives B. So now we are ready to construct the parsing table from this canonical collection of LR0 items. So this is basically, it is a DFA. You have the states, you have the transitions. So we have two operations, closure and goto, that we have discussed in the previous slide. Closure operation corresponds to the items that need to be grouped together, and goto operation corresponds to the transition of one state into another. So you have to just keep these two things in mind. So whenever you say closure operation, it is a grouping together of the items associated with the specific productions in the augmented grammar, and when you group together and make it a state, and those transitions that you have between these states corresponds to the goto operation. Okay, so before constructing the parsing table, let us look at these productions, the original productions once again. So we have S gives ASB and S gives B. Let us number them as we need to use them in the construction of parsing table. So we have two productions. One will be numbered. The first one, S gives ASB, is numbered as 1, and S gives B is numbered as 2, as we see here. Okay, so now we are going to construct the parsing table. We need to have the parsing table. Here we have sections. State, for state, the rows are of the parsing table corresponds to the states 0 to 5. So instead of I0, I1, I2, etc., we will use now those numbers 0, 1, 2, 3, 4, 5. Those 6 states, we'll be marking it here. And you have action section where the columns corresponds to the terminal symbols in the grammar. So we have two terminal symbols in the grammar, plus additionally we have that dollar symbol. So that is part of the action section in the parsing table. In goto section, we have the terminal symbols in the grammar. That is, here it is non-terminal section, non-terminals in the grammar. So goto corresponds to the non-terminals in the grammar. Here it is only one non-terminal is there, that is yes. So yes is mentioned here. So you have the states as rows, as well as the terminals and non-terminals form the columns of this parsing table. So action section corresponds to the terminals, and goto section corresponds to the non-terminals. So now we have to see how this parsing table is populated. So let us start from this first state, initial state of this this DFA. So here we have the transitions S, A, and B. So just keep in mind that all the non-terminal transitions that we come across in the DFA in this canonical LR0 collection corresponds to the goto section. So whenever you find a transition with non-terminals, you have to populate the goto section, and whenever you get a terminals from this terminal transitions in the DFA, that will be populated. The action section will be populated. So let us consider this first state, initial state, that is I0. You have a non-terminal transition, that is S to 1. That is 0 on S goes to 1. So that has to be indicated here. So you have to populate the corresponding cell. 0 on 0 on S goes to 1. So 0 on S goes to 1. So this cell for this 0 and S, this particular cell has to be populated with 1. So here we have it. Now the next transition here is 0 on A go to 2. Okay, so since it is a terminal symbol, that has to be populated here. So 0 on small a, you have a cell. So in that cell, what we need to do is, it is a shift operation that you need to perform. So any terminal symbol transaction corresponds to shift operation. So 0 on A it is a shift operation to state 2. So that is indicated as S2 in this particular cell. Okay, so 0 on A, it is a shift operation to state 2. That is what this means. So S2 means shift 2. Now let us consider this. 0 on B goes to 3. So 0 on B goes to 3. So here it is again a shift operation. So that is indicated as S3. Now for 0 state, you have 3 transitions. So those are indicated across this row for the state 0. So one is non-terminal, that is a go to operation. Go to section section cell that will be filled. For non-terminal, it goes to go to section, and terminals it goes to action section. That is shift operations S2 and S3. Now let us consider this next level states, that is 1, 2 and 3. So in 1 we have $, on $, 1 goes to an accepted state. So that is 1 on $, is accept. So that is 1 on $, goes to accept state. So here you need to indicate that as ACC. So it will be acceptance. 1 on $, acceptance. Now 2 on capital S, that is non-terminal, goes to 4. 2 on S goes to 4. So 2 on S goes to 4. So here it has to be populated as 4. Okay. Now 2 on A goes to 2 itself. 2 on A goes to 2 itself. So 2 on A goes to 2, that is a shift operation. So it is S2. And 2 on B goes to 3. So that is 2 on B goes to 3, that is S3 here. Okay, so all the 3 transitions of this particular state 2 is indicated here, that is A and B terminal transitions, that is S2 and S3, and for S it is 4. Now let us consider 3. So 3 you don't have any transitions from 3. So let us not fill it now here. Now go to 4. So here you have a transition. 4 on B goes to 5. So 4 on B go to 5. So here you need to indicate it as a shift operation. Since it's a terminal, it is a shift operation. So 4 on B, it is S5. Now on 5, let us consider 5. That is only transition in 4. In 5, we don't have any more transitions. So now if you notice, you have go to section filled as well as all the shift operations filled. Now and one acceptance also is there. So now another operation that you need to indicate now is the reduction operation. So as we have already discussed, when are you going to reduce a right hand side of a production to its left hand side? So that is indicated as that is indicated through this states with dot on the right end. So dot on right end means, see, suppose let us take this dot on right end means you have already seen this, the terminals sequence or sequence of terminals which could be derived from this particular sequence. So dot at the end means you have already seen this part and now you are ready to reduce it to S. So for reduction operations in the action section, what you need to see is you need to find out all those states with dot at the right end. So here you have I1, I5 and I3 have items with dot at the right end. So here it is we have already seen this S dash gives S. This is a special case where on dollar it goes to acceptance states. Now we are left out with these two, I3 and I5. That is on state 3 you have S gives B dot. So here you are ready to reduce it to S. That means you have a production which corresponds to this particular item, that is S gives B. This is the purpose of, now you have to see the number corresponds to this particular production, that is 2. So from on I3 or on state 3, you can reduce whatever the symbol you get on the input. Now you can reduce it. So that is the meaning that you have to take it from this particular state. So S gives B dot. So on 3, for any terminal you need to reduce using this particular production, that is S gives B. So on 3, for any terminal symbol that you find on the input, you have to do a reduction operation, that is using this particular using the production which corresponds to this particular item, that is 2. So you do a reduction operation using 2, the production number 2, that is R2. So across 3, for all the terminal symbols you need to mark it as R2. So that is what it is. For 3 on A, you need to do a reduction operation that is indicated as R2. 3 on B also you need to do a reduction R2, and 3 on dollar also you need to do a R2. So the purpose is, when you see a state with dot on the right end, you can reduce it with the corresponding production with any terminal symbol you find on the input. That is what this means. So 3 on any terminal, you have to do a reduction operation with the same production, that is S gives B, which number is 2. That is why we have numbered these productions. Now let us consider this I5, the state 5. Here you have S gives AS B dot. So here also you have dot at the right end. So the production corresponding to this particular item is S gives ASB, that is 1. So on 5, for any non-terminal you need to do a reduction operation using this particular production 1. So on 5, for any terminals you need to do a reduction, that is R1. So across 5, for all these terminals you will put R1. So here it is R1 for all the 3 terminal symbols. Irrespective of the terminal symbol in the input, you need to do a reduction operation using this particular production, that is R1. Okay, now our parsing table is complete. So we have completed the construction of parsing table. Now we will be using this parsing table only. We will be going to trace out a particular input string, and finally you will find out, you will do the bottom up parse, or the LR parsing will be doing using an example.